Good day and welcome back. In this video, we are going to cover the last topic in the capacitor, which is the discharging process. The learning outcome of this video is almost similar as the previous video about the charging process, where we are going to describe the discharging process of the capacitor, and then we also derive the formula of Q, V, and I. First, let us review back something that we have learned before, which is in chapter 13.4 that I've discussed about what happens if we add an uncharged capacitor. So when we have a charged capacitor that is connected to an uncharged capacitor, so first thing we learned that the potential difference across the parallel components should be equal. So what happened here is that they will perform the charge redistributions. So the charged capacitor will act as a temporary battery to charge the uncharged capacitor until both of them having equal potential difference. For today's topic, so we're going to see what happens if we add a resistor to the charged capacitor. So first of all, we know that a resistor is just a resistor. It cannot be like the capacitor to store the charge. So what happens is that the capacitor will continue to supply the current and the charge is discharged through the resistor. From here, we're going to look at what happens from the beginning until the end. So initially, the capacitor is charged with a certain potential difference. And then from here, we know that the resistor voltage is always equal to the resistor across the capacitor. And here the VR can be equal to I naught R, where I naught is the initial current when the resistor is connected to the capacitor. So from here, we can calculate the initial currents as the ratio of the V naught to the resistance. So after some times, the voltage across the capacitor will be reduced and the charge is also reduced. So from here, the current across the capacitor is still equal to negative C dV dt. So the negative sign here is actually indicates that the charge in the capacitor is reducing. Next, we're going to look at the derivations of the three variables. So first is about the potential difference. So we could see that the capacitor is in parallel with the resistor. So what we could see is that the voltage across the resistor is equal to the voltage of the capacitor, and they are equal to IR. So the next following step will be almost similar as what we have discussed in video about the charging. So we'll do a quick one. So first, we substitute the formula of I as negative C dV dt, and then we rearrange the formula and we perform the integrations. So the integration here is similar as what we did in the charging process. So I will not further expand about it, but if you have any questions, you can leave in the comment section. So we do the integrations, we do the substitutions, and then we rearrange the formula until we could get the formula of V equal to V naught multiplied E to the power of negative T over RC. And as we have learned that RC is a time constant. So after that, we're going to do the derivations for the charge, where charge is equal to CV. So substitute the formula of V that we have derived, and we can get CV naught equal to E to the power of negative T over RC. And we could replace CV naught as Q naught, where Q naught is the initial charge in the capacitor. Then we derive for the current, where current can be obtained through V divided by R. So you can also derive from other formulas such as I equal to dQ dt or maybe negative C dV dt. So from here, we substitute the formula of V, and we will replace the V naught over R as I naught, and I naught is the initial current in the circuit. And next, we're going to compare the charging and discharging process. So we have learned what happened to the Q, V, and I during the charging and discharging process. So during charging process, we can see that the charge in the capacitor is increasing, and the voltage across the capacitor is also increasing. So the current in the circuit is the opposite way, that it reduces exponentially with time when the capacitor is almost fully charged. And then during the discharging process, so we can see that the charge in the capacitor is reduced, the voltage is also reduced, and the current is showing the similar trend as in charging process, that it is also reduced exponentially. So we have derived the formula for each of these parameters. So we could see that there are two general graphs. First is the increasing graph, and second is the decreasing graph. So you can remember the formula, and also please do understand how can you derive the formula. Next, we're going to review what is the Q naught, V naught, and I naught are representing in the formula. So first, during the charging process, so Q naught and V naught is the final charge or the final potential difference during the charging process. And then as for the current in the charging process, it is the initial current. And as for the discharging process, all the Q naught, V naught, and I naught are referring to the initial Q, initial V, and also initial I, and all of them are reducing exponentially with time. Next, we're going to look at one of the trial questions, which is from Methodist KL. So this is the original questions. So we can see there's a switch S that can be connected either in terminal P or terminal Q. So when the switch is closed at terminal P, so we can see that capacitor 3000 microfarad is connected to a 6-volt battery. So when the switch is closed at terminal P, so we could see that the capacitor is charged by the battery. And then when the switch is closed at terminal Q, so what we see is that the capacitor now is connected to a 1 kilo ohm resistor. So during that time, capacitor will act as the temporary battery that will supply current to flow through the resistor. To solve these questions, first I'm going to identify what is time constant, where tau equal to RC. So we will get 3 seconds. And then we're going to identify what is the initial charge, initial current, and initial voltage. So first, the initial charge can be obtained using the formula of CV, and you will get 18 millicoulomb. And as for the voltage, the capacitor is the same as the EMF of the battery when it is fully charged. And then we can calculate the current using the formula of V divided by R, and you will get 6 milliampere. With these three informations, we can straight away derive the expression of the Q, V, and I. So first is the Q, and then the V, and then the I. So this three expression is not difficult to memorize. What you need to do is to identify the initial charge, initial voltage, initial current, and also the time constant to substitute in the general formula that we have derived. And then we also have another question, which is what happened after 2 seconds. Well, this is quite simple. So what we do is just substitute the T equal to 2 into the expression, and we could get Q equal to 9.24 millicoulomb, V equal to 3.08 volt, and I equal to 3.08 milliampere. So I'm sure the calculation won't be an issue for you. So I leave that for you to check on it. So before we end the video, so there's one more thing we can discuss is about the energy supplied by capacitor. As I have mentioned, capacitor will supply the current to flow through the resistor. So however, the resistor couldn't store the charge. So the energy supply can also understand as the energy loss through the resistor. To determine the energy loss, so what we can do is just apply the formula of E equal to half CV squared. So we can use other formula as well, depends on your preference. But for me, I would use this formula. So we substitute the value that the voltage across the capacitor is reducing from 6 volt to 3.08. And we can get the value of negative 39.8 millijoule. So the negative here indicates that the energy in the capacitor is reducing, and it is lost as heat energy through the resistor. There is also alternative solutions in the tri-bubble, which you can study about it. It uses the formula of energy equal to VIT, so not very difficult to study about it. So I will leave that to you to find out about the solutions. So that's conclude my discussion for today. So if you have any questions, you can leave it in the comment section below, and also do leave a like and subscribe my channel. I see you in my next video. Thank you.